Hello everyone. In today's class we are going to discuss on the topic capacitive transducers. I am Radhakrishnan, Assistant Professor in the Department of Biomedical Engineering, Hindustan College of Engineering and Technology, Coimbatore. So now we will see the introduction of the capacitive transducer. It is used to measure the displacement, pressure and other physical quantities. It is a passive transducer. That means it requires some external power for the measurement. The capacitive transducer works on the principle of variable capacitance. So if the input is varied, corresponding the capacitance is also varied. So through the variable capacitance, we can measure its corresponding equivalent. So the capacitance of the capacitive transducer changes because of many reasons like overlapping of plates, change in distance between the plates, and the dielectric constant. The capacitive transducers will have two metal plates and it is separated by the dielectric medium. And in the normal capacitor, the distance between the plates are fixed, but in the capacitive transducer, the distance between them are varied. The capacitive transducer uses the electrical quantity of the capacitance for converting the input to its corresponding electrical signal. The input quantity causes the change of the capacitance, which is directly measured by the capacitive transducer. So the equation shows the relation between the capacitance, area and the distance of the two charged plates. So here the area is directly proportional to the capacitance and the distance is inversely proportional to the capacitance. Epsilon is the permittivity of the medium. So we can replace the epsilon by epsilon naught and epsilon r, where epsilon naught is the permittivity of the free space and epsilon r is the relative permittivity. So the capacitive transducer is mainly used for the measurement of linear displacement. The capacitive transducer uses the following three effects. So the first one is variation of capacitance due to overlapping of capacitor plates. Second one is the variation of capacitance due to change in the distance between the plates. The third one is the variation of capacitance because of the dielectric constant. We have already discussed the relation between the area and the capacitance. If the area is increased, the capacitance will also have an increase because it is directly proportional. The capacitance changes correspondingly with the change in the position of the plates. That is, if the position of the plate is moved larger, that is, if the distance between the plates increases, the capacitance effect will decrease because the distance or the displacement is inversely proportional to the capacitance. So if the distance between the plates is reduced, we will have the more capacitance effect. So these capacitive transducers are used for measuring the larger displacement, approximately from 1 millimeter to several centimeters. Now we will see the angular displacement measurement. So in this slide there is a small spelling mistake in the measuring. So S should come here. The capacitive transducer is used for measuring the angular displacement also. It is actually mainly used to measure the linear displacement. It is also used to measure the angular displacement here. It is measured by the movable plate. It will be having a fixed plate and a movable plate. So the capacitance is measured here using the movement of the movable plate. So one of the plate of the transducer will be fixed and another one will be movable. The capacitance between them is maximum when the plates overlaps each other because the distance between the plates will be very less. In this case, will be having more capacitance effect. So the maximum value of the capacitance is denoted by the same formula, that is epsilon A by D, where A denotes the area and D is the distance between the plates, that is fixed plate and movable plate. Here the A can be replaced by pi r square by 2, the area. So the final formula for the C max is pi epsilon r square by 2D. The graph shows the characteristics between the angular displacement and the capacitance. So it's a linear curve. When the distance between the plates is varied, the capacitance also varied in this case. So we know that the distance and the capacitance is inversely proportional. So if the distance is increased, the capacitance will be reduced, and if the distance is reduced, the capacitance will increase. The one plate of the transducer will always be fixed, the other one is movable, so that we can have the variety of capacitance due to the distance or displacement move from the fixed plate. So you can able to see the graph between displacement and capacitance. So when the displacement increases, the capacitance decreases. Now we will see the sensitivity of the capacitor. So it is given by del C by del D. So if we integrate the formula for the capacitance, that is epsilon A by D with respect to D, so we will be getting the final equation as C is equal to minus epsilon naught epsilon R. Actually it is a substitution for epsilon. So the final equation is minus epsilon naught epsilon R A by D square, where A is the area and D is the distance between the two plates. Now we will discuss the advantages of the capacitive transducer. It will be useful for small systems. The capacitive transducer will be very sensitive and it will have a very good frequency response. The transducer will have high input impedance and it requires only a small output for the operation. It's a low cost device and it is also having high resolution. Coming to the disadvantages, it requires insulation for all the metallic parts. It requires earthing. The cable connecting across the transducer will also have an error in the measurement of capacitance. It is affected by dirt, humidity. It is non-linear and it is sensitive to noise. Thank you.